Okay, today I will show you how to do this statistical downscaling by using ClimDown, our package. So let me share the screen first. So by using this code, you can run your statistical downscaling by using a bias correction method. So let's go into the code. So this is the code. It's quite lengthy, about quite long. So this is not. We want to do statistical downscaling by using ClimDown package actually. So there's a lot of library you need to install. So for example, you need to install run library here, and then run the hydro GOF verification library, lattice library, ggplot2, f selector. If there is some problem with installing some of the package, so ignore it first, unless now and then library clean down, uh, and then mass package, evd package, caret package, and plotrix package. So for example, there is problem with installing f selector here. I don't know what's the problem actually, but it doesn't affect any of the code actually. It's still work very well, very well. So after installing and run all of this package, you need to run all of this. I think this is the internal coding to run the bias correction ID actually. So this bias correction ID is actually, I think it's from this website. This bias correction ID from this Santander Med Group. They developed downscale, but here we use a bias correction ID. 1D actually, 1D data. So here you just need to all of this method is bias correction. Actually, they have delta method, scaling method, EQM, empirical quantile method, GQM, GPQM, variance method, loci, and PTR, power transformation method. So all of this method you can run by using this code. But I will show you only the scaling method, which is linear scaling method. So you can run all of this method. All the description of the method you can find in many websites. Yes, uh, and it will give you some detail. Like for example, here in this workshop website, in the our documentation, it will tell you what is the delta method is what, scaling method is what. There is additive, multiplicative, EQM, GQM, and all of this you can find by yourself. So next, run this code, everything. Delta method, this for delta method, this is for scaling method, and then this is for GQM method, and then this is for EQM method. Quite lengthy this one, and then this is GPQM. Okay, GPQM, and then this is, yeah, I just run this one. I don't know actually. I get this code. I just run this, and then the variance. Oh, the variance method. That is another method just now. And then we have loci method. Run this, and then we have power transformation method. Power transformation is one of the best method compared with linear scaling. You can check on that one, but depend on your study area, the result might be different. And then run this, and then run this. Okay, that is all the code behind the scene. Now, this is the code that actually how to arrange all the data from your GCM. So here, so this is one you need to listen carefully. So first you need to set your working directory. For example, I want to downscale GCM daily GCM data. For example, I'm using Tmax here. But in your case, if you use daily, rainfall, wind speed or whatever, it's okay. But this is for daily data, and this code also can use for monthly data and whatever. So, but this one is for daily data. So we can go to our working directory here, set working directory. So let me see our data here. Heatwave. Heatwave, CMIP6. CityMix Global. Future data. Downscaling daily. Okay. So this is actually set the working directory that we put our observed data and future data. So for example, we have our observed here. You read your data set. This is our observed data for TMX. For example, I'm using ERA 5 dataset for TMX daily data for Peninsula Malaysia. So this data looks like this, looks like PM ERA 5. Okay, this one. So it takes quite some time to open the data because it's daily data from 1950 to 2022. So you have the data arranged like year, month, and day for the first three columns, and then the rest of the column is the grid point for this data set. So the mean here can remove. So I have 173 grid point for Peninsula Malaysia. For this is ERA 5 dataset for TMX data. So this is daily data. This is how you arrange the data for observed data. Observed data that you use for bias correction. So this is the observed data. And then, so you read your observed data from 1950 to 2014. Yeah, this is the range. The upper end is usually 2014 for CMIP6. So that you can compare apple to apple with CMIP6 data. So from 1950 to 2014, because the projection will start from 2015 to 2100. So this is the observed data, and then I need to run this one first. Okay. Okay. Now it's run properly. Now you need to read your projection data. For example, I have 4 projection data, which is under SSP 2.6, SSP 4.5, SSP 7, and SSP 8.5. So read all of this scenario. So make sure you have your data set, which is, let me see, PMF girl. So yeah, here. Yeah, these 3 data here. Four scenario here. For example, I open SSP 1 2.6. So it takes some time to open. Okay, now you have our data set here. The same thing, you have year, month, date, and then you have 173 grid point. So the data is here, month, date from 2015 until 2100. So this is the TMX, daily TMX for future projection under SSP 1.26. So, and then you have all other similar dataset for 4.5, 7.0, and 8.5. So you can read all of this dataset. Why is cannot open? Okay. No such file. Downloading. It's supposed to be. Make sure the name is correct. I think I need to put it like this, and it will be correct. Okay. Yes, file name. Make sure you have the correct file name for each of the SSP. Okay, now we have read all our scenario projection data, and then just read this one. T2, T4, T6, and T8 become T21, 50, 41, 61, and 81. And then you run this code, just run it, all of this, nothing changed. Okay, all the warning, just ignore it. And then the mode name here also you need to change, but this one you must change with your historical GCM, not observed GCM, not observed dataset, but historical GCM. So for example, we want to make a projection vice correction for model F-Goal G3, so you must get the historical data for F-Goal G3. So we have here PM F-Goal G3 T-Max. Okay, here. Yeah. So this is the historical dataset for this model, GSM. So you must arrange it also from 1950 to 2016 or whatever actually. Until 2014 is okay because it must similar with your observed dataset from 1950 to 2014. And you must have the same grid point, 173 grid point. So you have here month and date for the same column. So that is the data set here. So with this historical GCM, okay, and then you can just run all of this code, run all of it here. So for what important here is that you have 0.7 here. 0.7 here, that means 70% of the data is used for calibration. And then this is the method that we use. So for example, here we have scaling method. We have used bias correction 1D function to use scaling method. And then we also have many other method here also, but we also you can just run it. It will not affect your result. Where are we? Okay. Now run this one. So this is for each grid, each scenario just now, 2, 4, 6, and 8. And then we do this. You must decide the calibration and validation period. For example, for me, I want to do the calibration period from 1950 to 1992. So if you look at your data set, historical data, right? So you have from 1950 to 2014. So in your historical data, 1950 to 1992, you must 2/3 use for calibration, but this is, subjective. It can be 50% data used for calibration or 50% data used for validation or whatever. But in this case, I'm using 2/3 for calibration and 1/3 for validation. So how do you know this number? So you get from 1950 to 1992 for 2/3. 1950 to 1992. You see, we have about 15,700. 15,700. So I just put here 15,600, so it's okay. And then the rest is 7,300. You just read how many column here, the rest of it until 2014. 2014. It's quite big data set. So I have actually, we need to look down here, count here. You see 8,000. 8,000. And then, this kind, and then you run this code down here. You see this 15,000 just now. You can run here, put it here, slightly less, 15,000. And then from 7,300, you can put here 7,000. Yeah. And then make sure you change this number. If this here 15,000, here also 15,000, here 7,000, and here also change it with 7,000. Okay, now we print it. You see, it's if the is you see the in the console right now, bias correction is running. So this will take some time to complete. If you're using daily dataset, it will take some time, but not a lot of time. But and then if you use monthly data, then it can be quite faster also. So this will print all the result for all the bias correction method that you run for this model. Later on, you will compare which model is the best for bias correction method for same IP6 data for FG Gold G3. So after I run all this code, the result will be there. You can print the result and then you can put any set working directory that you want to put your dataset and your output. So here I put in the same folder actually, and then you will get your result for example, for calibration here. Here is calibration, for example, downscale. So let's see, downscale really, this one. This. So this is calibration, result for calibration. So the result for calibration, it will give you the result for each grid point. This is calibration. So this is calibration. You will have observation, GCM, and then this is the result for scaling methods. This is for gamma quantum mating, power transformation, and gain QM method. This is for the first grid point, and then you will have the second grid point, third grid point until 174 grid point. This is for calibration, and then you will also get your result for validation. So let's see validation here. So this validation also the same. You will have observation, GCM, scale, gamma transmission power, GQ, and for the first grid point. But it's up to you. If you want to do analysis for a scaling method, you can just take the scaling only, and then arrange the data for scaling only, linear scaling only. And then you will have this is the result for linear scaling method. You see scale. So this is the result for scaling. Let's see first. It's still opening because the data is quite big. Okay, it's there. Okay, you see, you will have the result was linear scaling for uh, SSP 2.6. You see here, SSP 4, SSP 370, SSP 8. So this is for actually for the first grid point. This one, the first grid point. This is for the first grid point. This is for the first grid point result, and then you have the second grid point here. You will have the result for SSP 2.6, SSP 4.5, SSP 7.0, SSP 8.5. So this is one grid point. This is the second grid point. This is the third grid point until 173 grid point. Because my study area would have 173 grid point, so the result will have 173 grid point. So if you want to do analysis for 2.6, you just need to take all the 2.6 only. You take the scaling, the result for scaling here. The scaling here. This is the scaling result. This is the raw GCM. So you can see, you can compare the raw GCM and the result for after scaling method here. You can do the time series. See, after bias correction, the result improve, but depend on the method that you use. So I think that's all for how to do this bias correction method. If you have any error installing the library, just let me know. I have troubleshoot some of the problem like carrot package or something like that. Some problem installing it because you need to do the run as administration method. You need to run as administration to install the library. But all the tutorial is in the YouTube. You can find it. I have prepared it. Okay, I think that's all. I hope this this code will, I will share this code with you right now, and then try to run it. If you have any question, if you don't know how to run it, look at this video. Okay, thank you.